Greetings, friends, fellow Earthlings, and most likely fans of all of the incredible data, the images, and information that we're getting from the James Webb Space Telescope being released right now. Welcome to Ask An Astrobiologist, the show that celebrates science and celebrates the scientists involved in our quest to understand the nature of life in the universe. I am Dr. Graham Lau, also known online as the Cosmobiologist, and we're brought to you by the NASA Astrobiology Program and SegaNet.org. As always, we want to say a huge thank you to all of you out there who are tuning in for the live stream or watching the recorded version later on, who ask questions in the chat, who ask questions on Twitter using hashtag AskAstroBio, and all of you out there who share about the show. Whenever you get a newsletter from NASA Astrobiology or from SegaNet, or you see our post on Twitter, if you share that information, we'll give you a shout out on the show, especially the profiles that do it the most. And so this month, we want to say a special thanks to the Space Telescope Science Institute, STSCI, for retweeting, sharing, liking, and commenting, and all of that awesome stuff on social media for us. It helps to have an audience who cares about what our guests are doing and about what we're doing. So thank you very much. Now, this month's guest, I met before in 2014 when she emceed a trivia competition and emceed the FameLab USA competition I took part in at AbGradCon. She's also a former project scientist in communications and outreach for JWST. Dr. Alex Lockwood has earned degrees from the University of Maryland and Caltech, and her previous research focused on understanding planetary systems and characterizing exoplanets. Before joining the Webb team, she worked on the NOAA-NASA Joint Polar Satellite System and at the King Abdullah University of Science and Technology in Saudi Arabia. She also starred in the film edit sequel of the PhD movie, and she loves running, yoga, and laughing with her kids. So Dr. Alex Lockwood, thank you very much for joining us, and welcome to Ask an Astrobiologist.
Hi, nice to see you, Graham.
Yeah, I mean, it's so great for me to see you again. And, we first met in 2014. It's a long time ago. And, I was a graduate student back then. I think you had just finished grad school maybe around that time.
Yeah.
And so, we've both kind of gone different directions in our careers now. We're both now more in the realm of science communication and sharing science. And so I'd love to talk about that. I'd love to talk about the work that you've done for the James Webb Space Telescope. But the one thing I love to start with all of our guests on this show is really to discuss your origin story that got you interested in science, in space, in life in the universe, and really kind of drove your career forward to where you are now. Would you mind sharing your origin story with us?
Yeah, sure. I think the reason that I got into astronomy overall was because I was always looking up. And, it's actually very unnatural for humans to look up from history, from evolution. We look around us or we look down because that's where our predators and our prey are. So it's actually, it's not a natural movement to look up. I was always looking up. And then in high school, I got to take an elective astronomy course. And I just, the possibilities, my mind couldn't stop racing with how cool it was. And I wasn't sure I could do astronomy because I wasn't sure of how strong I was in physics. But then I ended up taking another physics course in high school. And once I had a strong foundation, I then pursued astronomy. Another sort of critical moment for me was the first time I went to the Southern Hemisphere and seeing the Southern Cross and, the entire different sky of constellations. That was kind of a magical moment for me because you grow up and you see the constellations and they change throughout the year, but you have your set of constellations. And then to be in a different part of the earth and have access to a whole nother part of the sky and just realize what those constellations have meant to other people for years and years, that was pretty amazing, seeing the Southern Cross for the first time.
Oh, that's so striking. And I will say with this show, every single guest I have on always says at least one thing, if not 20 or 30 things that really surprises me. And I admittedly never thought about that, the fact that we don't really look up, like evolutionarily. You don't have a reason to look up. It makes me wonder if there's like some intelligent species of flounder out there that doesn't look down, because they're always looking up. That's really cool, though. And I think a lot of our audience can connect with that and connect with this, just the fact that we do look up and we see the stars and it connects us to the heavens and makes us want to know more. You eventually earned bachelor's degrees in astronomy and physics from UMD, and then went on to Caltech to study planetary sciences for your master's and PhD. I wonder if you can explain a little bit for our audience what your research was like when you were a graduate student and what you were pursuing.
Absolutely. Yeah. So I, through the course of my PhD, was able to study a few different things, all sort of based in infrared astronomy, which really dovetailed nicely into my work with James Webb. But in graduate school, I started off studying protoplanetary disks and the molecular compositions and modeling what is in the nebula around a young star, out of which planets form. And then later on in grad school, I actually went to studying exoplanets themselves, very similar techniques using near-infrared spectroscopy, but now looking at the end state of this planet formation and looking at a specific exoplanet where we discovered water. And yeah.
So I wanted to also talk about that just for a moment because that has a funny name of an exoplanet. I wonder if you can share that with our audience and maybe discuss the importance also of that detection.
Sure. So the planet that I studied was called Tau Boo B. It is the 10th star that was discovered in the Buddhist constellation, and because it's a planet, it is B. So I had to say booby so many times during my thesis defense. Yeah. But what was actually so we detected water in the atmosphere of this planet, which was cool in and of itself. I mean, and this was almost a decade ago. So we were really this was before a lot of the Kepler findings came out and whatnot. But I think what was cooler was that it was kind of a novel technique, and actually since then it's been it's been prodded and poked as we do in a scientific process of, is this the most rigorous technique? Everything with exoplanets for the past couple of decades has been cutting edge. And there's always somebody to come in and say, oh, my model's better, or, oh, I think you need to do the analysis a little bit differently. So it's been very cool to witness what has happened with those, that technique, especially over the past several years.
That's awesome. And one thing then, while you're doing this research in graduate school, you also then were lured in, drawn in, asked to be part of the PhD movie. I think a lot of people who watch Ask an Astrobiologist have probably read PhD comics. How did you get involved in that movie, and what was that like, kind of transitioning into doing an acting role as a graduate student?
Yeah, no, that was not something I planned for sure. So I, as a graduate student, loved PhD comics. I had them all over my door, in my office in grad school, always relating to them. And at one point, Jorge Cham, the author of PhD comics, lived down the street from Caltech. And he came to Caltech because he found out we had a theater department. And people had always been asking him if he would make a live action of some of his comics. And so we came to Caltech just kind of on a, what could we do together maybe thing. And it wasn't going to be a movie originally. It only evolved into a movie later on. So yeah, just kind of on a whim, I went and sat, in front of a camera talking to him in kind of a little interview style. Long story short, he offered me the main role. I did not tell my graduate thesis advisor at first because we were only filming on weekends and only one of the 2 weekend days. So I figured as long as I was working 6 days a week, I could take the other weekend day to do what I wanted, right, to make this movie. But my advisor's wife saw me one day filming on campus, and I got pulled into his office, just asking about my extracurricular activities. He was fully supportive, and we have a wonderful relationship to this day. But I can definitely say that I was caught with a little bit of pie on my face, telling my thesis advisor that I was also doing a movie.
I love that so much. I will say, so like for all of our younger people out there who are interested in graduate studies, but you're not quite sure the direction your career might take, for myself as well, during graduate school, I was doing a lot of science communication and volunteering at a museum and giving public talks all over the place. And luckily, my graduate advisor was very supportive of that as long as I was doing my research, I could also do my communication work. which eventually led into my career that I have now. And so it's important when looking for your own graduate advisors, for mentors, that you find people that you not only jive with for the questions you're asking, the research you're doing, but also for the other interests that you have. And so I wonder, just to kind of go off my own script here a little bit, Alex, if you could just talk to the importance of mentorship in general in your own life and how that's helped you advance your career.
Oh, absolutely. And I think we're both great examples, Graham, of how if you're interested in science, I wholeheartedly think somebody should study science. Do the undergrad, do the master's, do the PhD. And as much as it can, lead you down one specific path, we're examples of how by also following your other passions, you can do all sorts of stuff. And knowing science, having the background in science will only ever help you. For me, I actually switched advisors during grad school, my second year of grad school, which was the best thing I could have ever done for my mental health, for my career, and found somebody who I just thought was a really good person in addition to having good research. And the fact that, he didn't push me meant I pushed myself, which is really, an opportunity for growth. But he was always there to answer questions. And, I actually started a collaboration with another professor during grad school that was prolific in terms of what it led to. But it was also just because my advisor trusted me and said, go, explore what you want. And since then, I have had, I've had some incredible mentors also in communications, in strategic communications, in business. And, as long as you know what you are offering to your mentor, and you're willing to support someone else, receiving somebody else's support and guidance and trust is incredible. I don't know if that's all.
Yeah, I love that so much. That's great. And I say, from my own background, I had a student from 2 years ago just reach out to me recently. She's applying for a position now that she's finishing undergrad to do communications work in doing science communication, because she found out while working for me that she's also really interested in that realm too. And so I'm really hopeful for her in kind of exploring that realm too. And so since, finishing graduate school, you worked on the Joint Polar Satellite System, but you also went to Saudi Arabia and worked at the King Abdullah University of Science and Technology as a managing editor for a research publication, sharing the work that was going on at this university. I wonder, can you just explain for us, one, what that experience was, what you were doing there, and then two, how that kind of also then was part of your career transition to be doing more of the communications side of science?
Yeah, absolutely. I mean, that was, again, I never in my life thought I would move to Saudi Arabia. I didn't even think I would visit the Middle East. But what happened was that the president of Caltech, when I was a graduate student, he left Caltech to become the president of a university in Saudi Arabia. And when I was close to graduating, I kind of wrote him on a whim saying, hey, we might have some opportunities through my PhD comics work to showcase your university. Are you interested? That led to some discussions, and he just offered me a job to do the communications and outreach for this university. He said, you've got a good head on your shoulders. You've got a PhD from Caltech. You can probably figure this out. But he'd also seen all of the extracurricular work I did during grad school. We did a YouTube series called PhD Tours and all of this other stuff. So I did a complete 90-degree, turn in my life and my career, moved to the Middle East, to a different culture, and a different career. Fortunately, I had his support and another boss who was very tough, but taught me so much. I'm incredibly grateful for all that she taught me. And then I lived in Saudi Arabia for 2.5 years. Which was incredible to learn about how, it's one thing to go into a different job in a different organization, but to go to a completely different culture is just a whole nother layer of learning how to deal with people and how to make the most of situations and how to really, navigate things carefully but intentionally. But it was so cool too. Up until a few years ago, you couldn't just visit Saudi Arabia. You had to have either a work visa or a religious travel visa. And so being there when a time that almost nobody else could ever go to that country, and seeing some of these incredible like hidden gems, Nabatean ruins, which are they're funeral sites. They're tombs that are carved into the side of stones. And there's two famous sites for them. One is Petra, Jordan, which a lot of people have visited, which was highlighted in the Indiana Jones movies. But then the other set of Nabatean tombs is in Saudi Arabia, and almost nobody, has ever, millions of people have visited Petra, and only thousands of people have ever seen the ones in Saudi Arabia. So I got to go see those and just travel all around and meet people from all of these different cultures. It was fantastic.
That's so incredible. And I love how like our conversation so far, like it sounds like your career, there's little pieces that kind of tie everything together along the way. The PhD comics helped with going to Saudi Arabia, and that kind of helped them too in the transition of your career in communications. But you also have a strong background in the sciences and having done research with infrared astronomy and trying to understand, what we're using and looking out there with something like the James Webb Space Telescope. I know a lot of our audience wants me to jump to JWST as soon as possible, so we can do that. You were the project scientist for communications and outreach. Before we talk about the data from JWST, what it's doing now, maybe some of the stuff for the future, I wonder if you could explain what the job is of a project scientist in communications and outreach and the work that you were doing for the Webb Space Telescope.
Yeah, so that's a good question. I think there's a lot of different project scientists can mean a lot of different things in missions, but it's seeming to me that more and more NASA missions are having project scientists for communications, because it's so critical, not just to do the communications, but to make sure that there is a very strong connection to the science. And so having somebody with a science background who's then dedicated to doing the communications means that they can work with the scientific staff to ensure accuracy, but also with the communications folks to ensure that things are distributed strategically and meeting all of the different audiences that we have nowadays. So that was kind of my job, was to help make the connection between the science that James Webb will do and now has done. So excited for that. And all of the different methods that we can share that with the public, from public exhibits to social media to news stories, really telling that scientific story, and just making sure that it's really, really based in the science that is the most relevant and connects to the audience.
It's incredible. And I love this idea, too, of having a strong science background. It makes you a stronger communicator when you're communicating science about something like a NASA mission. That's super critical to have that background. And I will say now, our producer and director, Mike Toillion, has asked that we ask you to give us a rundown, basically, of the images that were released so far from JWST, since you were so involved in those releases and bringing those data to the public for us to understand. The first image he's going to show to our audience here is the first image, the deep field image of SMACS 0723. What are we seeing in that image?
So the SMACS 0723 is actually the galaxy cluster at the center of the image. We use galaxy clusters as gravitational lenses to actually see further back into space and time. And so this, you see here, you see all of the background galaxies, which you see in any image in Webb. You can't not see galaxies in a Webb image. It is so sensitive, and there are so many galaxies out there. But it's centered on the center star cluster to help bend and focus light from distant galaxies. And in this image, there's actually a handful of galaxies that are older than 13 billion years. And this was taken in just a matter of a few hours, as opposed to Hubble deep fields, which have taken on the order of 100 plus hours. So, this is really just scratching the surface of how deep into the universe Webb will and can look.
Oh, I love that. Yeah, it's just the drop in the bucket of how far we're going to go here and looking to the earliest moments of time that we know of. The next image coming up is the Karina Nebula. I think this one is now being used as the most wallpapers for people's desktop computers and laptops. And I had some students on a recent trip for Smithsonian, and a bunch of them had it as a wallpaper on their smartphones now. So what are we seeing in that Karina image?
Oh my God. Let me just tell you that I was in the room like the morning that this data first started coming down. We downloaded the first raw FITS file, single filter, completely unprocessed, out, down from the telescope through the pipeline, put it up on the screen, and I had a tear in my eye. This data has been gorgeous from the beginning, and I'm so incredibly amazed by this image. This is a star forming region, so within this cloud there are thousands of little stars that are forming, and they create all sorts of crazy shapes that you can see if you explore the detail in the image. And actually, one really fun little thing that if you look really closely, sort of at the right where the nebula meets the rest of open space, sort of towards the center, there is you can see where a star is embedded and the jets from the star that are propagating both into the nebula, but also you can see they've broken through the nebula, and you can actually see ejected material all the way up at the top of the image if you follow the line. So this is a little scavenger hunt for the listeners out there to go find that, because it's so cool. We can really study the medium and the material by seeing this physical process in action.
Oh, I love that. Now I have to do something after the show too. So now we're seeing the earliest moments in time. We're seeing star birth and formation. The next image coming up is the Southern Ring Nebula image. There's two of those side by side. What are those showing us?
Yeah, I call those the eyes. So this is two side-by-side near infrared and mid-infrared images of the same object. Both of these images were taken by James Webb because it has capabilities at both of these different wavelength ranges. And this is a dying star. So this is a planetary nebula. So it's a star that's not super massive, maybe like our sun. And it has died. And in the process of dying, it has expelled its outer layers of gas. And those outer layers of gas have created new molecules. And it's this very intense environment that really, when Carl Sagan said, "We are made of star stuff," this is what he meant. Dying stars create all of the molecules and building blocks of life as we know it. So that's what we're seeing here. And it looks really cool. You can just see you can see all of the physics going on. It's crazy.
I love that so much. There's also an image called Stefan's Quintet showing kind of like a globular material of galaxies kind of around each other. What's that showing us?
So that is a set of interacting galaxies. And in fact, it's kind of hard to tell, but there's 5 galaxies there, but 4 of them are interacting. And then there's one kind of off to the left side if you're looking at the image. That is a foreground galaxy, but the 5 of them look together, so they're called Stefan's Quintet. And you can you can see the interactions of the galaxies. You can see the dust being ripped apart as these galaxies at the top have been moving through each other. And you can also really see great detail in the single galaxy on the side by itself. Infrared wavelengths bring out dust features, which is really complementary to what you can see with Hubble image, because Hubble really brings out stellar features and hot gas. So together, you get a much better picture of the full extent of what's going on in the galaxy.
Oh, fantastic. So we have the birth of time as we know it, the birth of stars and planets, the end of solar systems. We have interactions of galaxies. And now one that came out fairly recently that has been shared on Twitter and Instagram and across the internet literally millions and millions of times now is the image of Jupiter that just came out. That's a really stunning image. What are we seeing in that image we don't normally see with visible light?
That's a good question. So again, at infrared wavelengths, you're studying certain molecules. So we're seeing molecular signatures in the atmosphere of Jupiter, just like we study with Webb for exoplanets. We are studying, and so you're seeing those the banding, the structure of the atmosphere from those different molecular signatures. It's a really cool image, and I know people were really excited to see something so close. Our good old buddy Jupiter.
Yeah. Just the fact that this telescope has that resolving power too, to see things so well in our own solar system, in solar systems nearby, and to the beginning of time is incredible. We did through the NASA Astrobio Twitter account, which is at NASA Astrobio. We asked our audience of all the things that JWST can teach us, what do they find most exciting? Now, to be fair, these are people who do follow an account called NASA Astrobiology. But we gave them some possible answers: exoplanet atmospheres, the early universe, galaxy formation, or stellar and planetary birth. Of all those possible answers, over 60% of the respondents from 193 votes said exoplanet atmospheres. And as an astrobiologist, like, okay, it's hot. All the images are beautiful. Karina is beautiful. It's stunning. But as an astrobiologist and someone who wants to know if there's life out there in other worlds, these exoplanet atmospheric data are kind of the coolest thing. And there's some data were released right away, which showed us water in an atmosphere of an exoplanet. And then just today, we found some new data showing us something also very awesome. Would you mind telling us what we released today, and maybe what we're going to see in the future for exoplanet atmospheres from JWST?
Yes. Yes. We saw CO2 for the first time ever. So just this morning, you know, how serendipitous is today. Just this morning was the first science peer-reviewed publication based on Webb data. It's a paper in Nature led by a whole team of exoplaneteers. And it is the first ever discovery, the first ever confirmed signature of CO2 in an exoplanet atmosphere. It is the first science result from James Webb. It is the undertaking of a collaboration of, it's almost like 100, I think, different people who came together to propose time together on James Webb and make that data immediately publicly available, because they were all so passionate about forwarding exoplanet science that they didn't bother bickering over who was going to be first and this is my data, whatever. They all got together and they said, these are our priorities for what we want to study so that the science can just start flowing. And that is exactly what they did. It is, I mean, I am fortunate to know a lot of the people on that team through my previous work. And not only they're cool people, but I mean, they've just proven what their, you know, how great their science is, how great this observatory is. I couldn't be more excited.
I love it. That's so great. I love this collaboration too, working together to bring the science forward so quickly too for all of us. I mean, these are results coming out really fast after observations have begun. So there's a lot more ahead of us as well. And I know, so there's a bunch of questions rolling in from the audience right now. I promise to our audience on YouTube, I will get to your questions as soon as we can. But one thing from me then is what are you looking forward to for the future of JWST observations?
You know, I think that the exoplanet possibilities, and really with James Webb, we have the opportunity to study in detail these exoplanet atmospheres and also study in detail where planets were formed. And so we have one tool that can help us study the entire life cycle of planetary systems and put pieces together, because it's not just what do we see in exoplanets? It's how did it get there? Why? Why do we see this diversity of exoplanet systems? You know, how do we explain our own solar system that now seems like an anomaly from what we found? You know, and being able to start from the beginning and say, this is the raw nascent material from which the star and the planets formed, and let's take that and evolve it all the way to fully formed systems. JWST just has such incredible capability, such incredible resolving power and sensitivity to study the entire evolution of planetary systems.
Yeah, absolutely. There's so much more ahead. I will say, just for time's sake, I want to jump to our next segment, which are our faster than light questions, our rapid fire questions segment. Just a few questions. If you can give it as an answer in like 30 seconds to a minute, just a few things to poke and prod about your interest in the universe and space and other things like that. So the first question is, with regard to aliens, what's your favorite answer to Fermi's question, where are they?
I would say it just hasn't been enough time. I mean, 100 years of trying to communicate is a drop in the bucket. So they're there.
Okay, and then for me, I love reading books. I also play a bunch of video games. What kinds of stories have inspired you to want to explore more about life and the universe or space?
So definitely Ray Bradbury, and also Contact. I was in middle school when that movie came out, and Jodie Foster. Oh, that was incredible.
Absolutely, yeah, Contact is so. So here's the career one. If you could go back in time and visit yourself at the beginning of your career, whenever you consider that to be, what advice would you give Alex back then?
Well, two pieces of advice. One is just keep doing it. You're going to be fine. And the other would be study atmospheric science, because I think climate change is really important, and I wish I could be contributing to that.
Yeah, yeah, and then it's kind of then ties into this next question in some ways. If you could ask a question of humans 100 years from now, what would you ask them?
Um, well, I guess that they're alive, so that answers one of my questions. I would say, well, I guess at this point, do you wish that you had taken more risks? Maybe.
Mm, I like that one. And so then, what is something that excites you about the future?
I'm going to go personal on this one. I just started my family, and I'm really excited to watch my kids grow up.
Oh, I love that. That touches my heart. I have a 3-year-old now, and it's just fun watching his brain develop and watching him learn, and being part of that process for him is incredible. I love that. So our final question, and this is kind of a fun one. What's maybe an unbelievable science fact that still blows your mind?
Um, that there are 3,000 galaxies, and there is 3,000 galaxies, and there is 3,000 galaxies. And anywhere you point, you're pointing at thousands of galaxies.
No, I love that. We are not alone when it comes to the amount of stars and galaxies out there in the universe, and it makes a lot of us wonder for the possibilities for alien life out there. Hence, astrobiology. So I do want to get to the audience Q&A now because I see a bunch of questions rolling in. So thank you to our production assistants, Mariam, Naseem, and Anurup Mohanty, for bringing those questions to us from YouTube and Twitter. So the first question comes, and this came just before we even started talking in our episode, from John Rosenfield from YouTube. John wants to know, using spectroscopy with JWST, which atmospheric chemical signatures of life are we looking for?
It's a good question. So we are looking for CO2. We are looking for water. We are looking for methane. We're looking for nitrogen. And actually, a very unique part of JWST is that when you go further into mid-infrared wavelengths at around 9 microns, there's actually a signature from ozone. So that's also a very interesting one that we can get with JWST.
That's very cool. Yeah, there's so much that friends of ours over the years have been doing and compiling these databases of what biosignatures could we look for, will we look for, will we find, what is an A biosignature. So there's a lot of great research there. Our next question comes from Andy Oates from YouTube, and it's intriguing for me since I don't actually know Webb's resolution for moons in our own solar system. Andy has asked, could Webb's telescope instruments offer any help in looking for life in our own solar system, such as looking at moons like Enceladus?
So yes, we can look at moons in our own solar system, and there's a lot of programs that are geared towards that. I can't, off the top of my head, recall the resolution, but you can easily find online the plans, and it is to study the surfaces and atmospheres of moons. Atmospheres, lately, I mean, where they are.
Yeah, very cool. Our next question comes from Jim Pass from Twitter. Jim runs the Astrosociology Research Institute. He always has questions for our guests for Ask An Astrobiologist that consider the human factor, the sociology side of things. And so his question is, how will JWST discoveries impact on human societies, perhaps surpassing the impacts of previous telescopes?
So there's a few things here. One is seeing the earliest galaxies, really helping us understand, the closest that we can to the Big Bang, except for the CMB, which is just like kind of a blob in my opinion. But really understanding the origins of humanity, and then the origins of our solar system, as I talked about before. People want that. They want to be kind of validated that either they're really special or that they're really not special. And both of those answers seem to jive with people, but they want to know. And then I'll also say, just in the past 6 weeks since Webb first got its first images, the number of articles that I've read from very curmudgeonly journalists who were questioning Webb for years and years and years, now having a renewed appreciation for NASA, for astronomy, for the cosmos, for science. I think that is the value of astronomy. First and foremost is the wonder that it gives people, the inspiration, the hope. For example, climate change, we need to be pushing the boundaries of what's possible to solve those problems. And with things like Webb, we renew the public's and the scientists' desire to push those boundaries, to find solutions, to break technological barriers that were previously in our way. So we have to keep thinking big. We have to keep pushing ourselves. And it's mind-blowing what we can do and what's out there.
Oh, indeed. And, it's inspiring for the coming generations as well, for younger people. And they are the ones who are going to need that work, the inspiration, the curiosity, the drive to, unfortunately, fix a lot of the problems that they are inheriting from previous generations. And with that said, we actually have someone from a younger age group joining us here today in the chat. So Shayak Faruqi is asking on behalf of a 6-year-old named Zunaira. Apologies if I pronounced that wrong. I believe it's Zunaira. There are 2 questions. I'm going to answer one, and then we have one that I'd like you to answer as well. One question is, why are there holes on Mars? Zunaira, I'm going to guess that you mean the big craters. They kind of look like bowls on the surface of Mars, like we have on our moon and on Mercury, and actually on Earth too, and all throughout our solar system. Those are big holes that form when big rocks from space fall onto a planet. They excavate, they dig a bunch of material, and they pick it up and they blow it out, and they make a big hole in the surface of that world. And it's actually those holes that let us figure out how old the surface of Mars is. The more holes there are, the older the area is that we're looking at on Mars. But yeah, so we have craters on Mars. There's also some other kinds of holes, like there's a big crack called Valles Marineris. It's a big canyon on Mars, and it's really, really deep. It's as far across as the United States is from one side to the other, so it's really big. And there's also some other holes that are made in something called lava tubes. These are caves. If you've ever seen a cave, it's a big hole in the ground. The lava tubes on Mars form from volcanoes, which is pretty cool. Now, Alex, Zunaira's other question is also a really fun one. They want to know, why don't aliens come to Earth?
That is a good question. And to stay none, I think that the answer is that the nearest star is so far away that even if there were very, very advanced aliens, even more advanced than the human race, and even if they started trying to get to us 1,000 years ago, they probably still wouldn't have gotten to us. So space is just really, really, really big. And so that's why we use light as astronomers to communicate and understand the universe, because light travels much faster than humans or probably aliens could ever.
Oh, yeah. Space is vast. It's mind-bogglingly big, as sometimes called it. We have a question coming in from Twitter from @MyStupidTown. It's an interesting name. They are the Travis DeCoster. I'm not quite sure what Travis is referencing here. Travis asks, does this discovery in any way change our understanding of this particular planet? or reveal anything new? I'm going to guess that Travis is asking about the CO2 data released today, would be my assumption.
That is a good question. So I haven't fully read the paper because it just came out today. But CO2 does tell us about the history of the planet. It traces the solid material and the gaseous material from the planet's history. So yes, it will tell us more about the history of the planet. And I'm sure that scientists are working right now to figure out the exact structure of the atmosphere given this new data.
Very cool. And then I guess a follow-on then from us, and maybe Travis also was referencing this, for the Jupiter image that was just released, are we learning anything really new maybe about Jupiter that we didn't know before, or is it just confirming some things that we knew using JWST for Jupiter observation?
That is also a good question. And there hasn't been any science that's been published. That was just the image. We will be learning about the atmosphere, the storms on Jupiter, the magnetic fields, all of that stuff from James Webb data. But the image that came out just this past week, there's no scientific results published yet. It's just the image. So stay tuned.
Awesome. And there are still a bunch of questions rolling in to our audience, asking questions in the chat. Thank you so much. I'm trying my best to get to them. Alex is doing such an incredible job answering them. It's making me super excited. So our next question comes from Son of Overbrook on YouTube. They want to know, they say, Dr. Lockwood, what was your first telescope and how old were you?
That's a good question. And unlike probably most people in astronomy, I did not have my own telescope growing up. So the first time I really got to use a telescope was in undergrad. And the University of Maryland has a little observatory with a few, I think they're like 12 maybe inch. We had to do a thing for astronomy where we went out to the observatory in the middle freezing of the night, and I saw the Ring Nebula for the first time and was just floored that I was standing here and just directly witnessing something in deep space. Yeah.
Very cool. Yeah, I was the same way as a young child. I never had my own telescope, unfortunately. I was 12 when my cousin let me use his telescope, and I saw the rings of Saturn for the first time. There's lots of ways to get intrigued in astronomy and learn about the stars, and it can happen at any age, really. We have a question from Elisa MS on YouTube. Elisa asks, this is a really fun one. How can they improve their communication skills?
That is a good one. So communication is about the message received, not the message sent. So the best way to improve your communication skills is to try to tell someone, have a message in your head, try to get it out to someone, but then ask that person what they heard, what they took away, and don't do it immediately. Give it an hour or a day or a week, and see what they hold on to, see what they take away. And then you will learn what it is you're transmitting. You'll start to learn things like the story that you use to tell the anecdote, the tone of voice, the specific details, or the high level picture, how all of those things really play into what your listener is receiving, which is the most important thing. So ask people what they heard you say.
I love that. Yeah, that's a great idea for me too as a communicator is to ask my audience, like what did they hear from me? I love that so much. I guess that I'm going to ask my own question. I'm so sorry for our audience watching, but that gets me intrigued. I'm part of several different groups who are interested in sending messages into space via radio or other communication methods, or like the Voyager Golden Records, sending, actual physical devices into space with a record of who and what we are. If you could choose anything from your life or from humanity, what we've done on the planet, our history, that would go in a message via radio or a new Voyager Golden Record, what do you think you would want to choose to put on that record or that message?
For some reason, my head just wants to say ABBA, which is terrible, and I have no interest in ABBA whatsoever. That was the first thing I thought of. That's a really good question, and I would I would probably say some like the sounds of water running, maybe, because it's just so inherent to what we know as life, and and sound. I just there's something beautiful about that. It wouldn't be aggressive. It would be welcoming. It would give us an opportunity to open the conversation. Maybe I don't know.
Interesting. Yeah, I love that idea. Running water. Cool. We have another question from YouTube. Marina Ripan asks, what inspires you the most about the capabilities of JWST?
The capabilities of JWST inspired me the most, which is totally a backwards answer. But the fact that we did it, that's what inspires me. The fact that people said, I have this outrageous scientific goal and it's never been done before. And we have to build a foldable rocket and we have to invent all of these new technologies. And then they said, well, whatever it takes, we're going to do it. We're going to, it's worth it. That's what inspires me, is that we never stopped. We just said yes and to every challenge.
I love that. Yeah. Just moving forward. Another question from CP Studio on YouTube. What exoplanetary data have been gathered so far? And when searching for alien life on known and nearby Earth-like planets will be performed? I think they want to know if what time has been spent on places like TRAPPIST-1 and PROX-B and some of those places already. I'm not sure if you're allowed to share that with us or not. But I guess their question is, are we doing these searches right now?
Yeah. If you go and look, you can find out what a JWST is observing. As of 10 a.m. July 13th, July 12th, everything that JWST has been doing has been made public. So you can go online and you can see exactly what James Webb is studying. And so, yes, we have looked at a lot of exoplanet systems so far. Obviously, the two WASP planets that we've already had results from. But yes, there have been a lot of exoplanets, including some potentially rocky worlds studied so far. So we're well on our way.
Yeah. So we had Natalie Battaglia on the show, for instance, and she talked about how some of our very first worlds we were planning on looking at could include TRAPPIST-1 and some of these other systems that are very intriguing. And so I think it is important for the public to remember that it takes time. So this telescope's doing incredible things, and the data we've seen so far are very short observations. Some of these observations take more time, but then also analyzing the data and understanding it and interpreting it and doing it a very good job scientifically before you release those data are super important. So Alex, I wonder if you can just speak to that importance of the process, maybe, of why it's taking a bit more time for some of those other data to come out.
Oh, for sure. I mean, and it is, I think, 43 days since Natalie Battaglia and her team got that exoplanet data. Maybe less. I'm not sure exactly when it was taken, but in most 43 days. And the fact that they have peer-reviewed results is incredible. I mean, what happens is you get some data, but that data is, especially with exoplanet data, it's data from the exoplanet, but also from the star, from transmission spectroscopy. You have to figure out what is what, and that is very model dependent on what you think is in the atmosphere of the star to subtract that. And then, and what we do in astronomy, and I mean, I believe in science, but I can only speak mostly for astronomy, is that you have models and you have data. And what you do is you use the models to try to match the data, but then you use the data to better create your models. And so scientists take time to kind of go back and forth. They don't, you can't just look at something that you think is, at this wavelength and say it's that feature, because you have a lot of other things to check. Is it moving? Is it something else? Does that make scientific sense? Is it consistent? So there's just a lot of checks. And then there's the process of writing a scientific paper, submitting it, having it be sent off to other scientists to review the accuracy and rigor of your work. And I mean, really, that's just, that in and of itself is going to take days, weeks, because we don't just make a decision as a scientist with data and say this is what it is. We have other people try to disprove our theories first before we say, okay, this sounds like it could be the truth.
Yeah, and that's some of the beauty of the tool of science and why it's been such a powerful tool for us to understand our place in the universe and ask questions about what life is and how stars are born and what might be in the atmosphere of an exoplanet. So we have a joint question now that's been kind of combined here. So Karen SY and Niall Gaikwad on YouTube, they have two questions kind of similar, so we have them together. Are there any important biosignatures, perhaps, that JWST can't detect? And then maybe with that as well is what would you say are some of the shortcomings of JWST that maybe we would want to improve in future telescopes?
So biosignatures that JWST can't detect. Trying to, you'd have to tell me what the complete list of biosignatures was, and that's, so I'm going to kind of punt that one. JWST's, JWST was thought of 20 years ago. So some of the instrumentation and whatnot is, a little bit, is not as advanced as it could have been if it was built today. So we could have higher resolution spectrometers. We could have a more sensitive chronograph instrument. And all of these things are improvements that we're making in the future. JWST has the ability for the first time to really start studying the atmospheres of smaller rocky exoplanets, but it's going to foray into that area of exoplanet science, but it's not going to fully characterize them. And again, this is just, JWST is a huge leap in technology and in scientific advancement, but the beauty of science is that there's more to do. It's weird to get a question about the drawbacks of such an incredible machine, but it is a machine, and it was initially designed 20 years ago. So everyone's evolved in the past 20 years, and so has technology. So it's
yeah, things change. And there are some other concept designs. There's things that might happen like LAVOIR, this large UV optical infrared kind of mixture for a telescope. There's been concepts like HabEx and some others. There's also been things like proposals to build a satellite or a telescope that would basically travel kind of like a light year away from our solar system and then look back and use our sun as a gravitational lens to try to image the surfaces of other worlds. So there's a lot of things that are possible, and who knows what might be probable. Maybe we have some young undergraduate or graduate students, or even maybe our 6-year-old student who's watching right now. Maybe in your future, you'll be part of some next great telescope or next great project that we collaborate on together, and we do something incredible to learn more about our place in the universe. And so we are always changing. We are always kind of evolving and building more on the past. So from that, Alex, we have a question from Andreas Hess. And I'm having a hard time reading the question. It says, how often can we expect news? Oh, I see. How often should we expect these data releases, I guess, is the question that we have from Andreas.
That's a good question. And I know a lot of people since first images have been just salivating for new news. As we just said, scientific process takes a while. So the fact that we got the first scientific results today is kind of incredible. But knowing how much data James Webb is taking, I think that it is reasonable to say that, in September, there'll be more news. In October, there'll be more news. And, by the end of this year, it'll be flowing in very consistently. So that's my best guess.
Very cool. This next question I really like. It comes from one of my production assistants, Anurup Mohanty, asked this for us. I will say, so Anurup is a young man from India. He reached out to me years ago through social media, and he was interested in astrobiology and just started a conversation with me about possible ways to advance his own career and learn more about biology and chemistry and geology and those kinds of things. He was part of a rover team that built a Mars rover that competed in a competition that I helped to manage called the University Rover Challenge. Sometime after that, Anurup applied to work with me as an intern, and he got in and he worked with me, and then became a visiting scholar in my company working with me, and now he's a production assistant for Ask An Astrobiologist. So for those out there who are wondering about building your careers moving forward, reach out to people who you are interested in getting to know more about what they do and how they do it. Many of us are happy when we can to try to answer your emails and your messages. And don't be disheartened if we don't answer, but we love answering you and trying to help you find your own career moving forward. And so Anurup is still discovering his career right now. And so Alex, for you, he has a question about this. He says, when we think about science communication, we tend to think about people talking to the public about science, the sage on the stage, the person just sharing the knowledge, but there's certainly more. Can you share what else you do in communications, and maybe what skills someone can gain to work in a field like communications for science?
That's a really good question. Yeah, and to what you were saying, Graham, those of us who've furthered our career a bit in this, and having had great mentors, I, for one, always look for opportunities if someone reaches out. Like I love to mentor other people and help them and give any, support or, guidance that I can. There are so many ways that you can take a science career and move more into communications. There's tech transfer. I don't do that specifically, but helping take science and turn it into technology or vice versa, or new tools, things for the benefit of society, tangible things. That's a hugely important area. And one of the reasons we do research is for the benefit of humanity for tangible outputs. And in terms of communication, a lot of what I do is coordinating with other people, making sure that, not just talking to the public, but making sure that people internally are talking and saying the same things, making sure that, if we're trying to get from A to D, we go through B, C, and we don't have 25 pit stops along the way. Clear organizational skills, being able to see the big picture and then break it down step by step is a hugely important skill, and one that is not as ubiquitous as you would think. And listening to people, talking about communications, listening to people. And then there's a lot of people who just write. They just, you don't have to deal with people day to day. You just write. And then that is your main form of communication. And, you can reach a lot of people, but you don't have to worry about stage presence or any of that. Written word goes so far, and if nothing else has the most longevity. And so being skilled at that and being able to use words to tell the science in different ways is really important. So there's a lot of different opportunities out there.
Oh, I love that so much. That's so powerful. And I think we're going to have to end there, unfortunately. We are coming to the top of the hour now. So thank you to everyone for all of your wonderful questions, for jumping in on YouTube and on Twitter, for asking questions of Dr. Alex Lockwood here today, for Ask An Astrobiologist. I know we had a few more questions that we just don't have time to get to, unfortunately. Is there any last message you might want to say to our audience, Alex, about your career, about JWST, or what you think the future holds for us?
Yeah, I would say, especially for an astrobiology audience, there is so much potential out there, because astrobiology is it's an interdisciplinary area, which means that the science from both astro and biology, but also physics, chemistry, all sorts of stuff, those are all critical pieces to fit together. And the communication between those different groups is going to be critical to really be able to maximize the output of the science. So I think that there's so many opportunities in this field, and that if people want to do the science, they want to do the communications, they want to do some of both, you guys are primed to really inspire the next generation. So that's awesome.
Oh, I love that so much. Alex, thank you so much for joining us for the show today.
Thank you. It's been great to see you, Graham, and hope everybody out there's enjoying all this cool web stuff. Yay!
I know there's so much coolness already and so much more to come. So for those who are watching, if you want to stay in the loop for upcoming episodes of Ask an Astrobiologist, or just get more news from NASA astrobiology about cool things, including maybe opportunities for young students in the realm of astrobiology, you can sign up for the NASA Astrobiology newsletter. They send out all kinds of cool emails about current things going on throughout our community, through the science, the missions, opportunities, events, and more. So to Dr. Alex Lockwood, to all of our audience out there watching live and the recorded version later on, thank you so much for joining us. And as always, until next time, stay curious.